Am I audible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Very good. I request all of you to mute your mics and turn off your videos also. Let us enter into the subject of systems 2. You have already studied power systems 1, where you have learnt about construction, operation principles of various generating stations, operational aspects, and various issues that are to be considered for economical operation of the plant, and the tariff with which we have to charge the consumer for his utilization of electricity. It is extension of power systems. Extension in the sense, these generating stations are usually located at remote areas as per the requirement of source energy. See, if it is a hydro plant, it will be located close to the availability of water. If it is thermal plant, the optimal location will be selected based on the availability of coal and water. Nuclear plants will be usually away from dense populated areas. So the consumers are finally expecting the power generated at the stations to be used at their premises. There are several types of consumers: domestic, industrial, commercial, agricultural, etc. How the power generated at the stations has to reach the end consumer is what we are going to discuss in power systems 2. That is the extension of power systems. For this purpose, we'll be using various lines. The lines are categorized as transmission lines and distribution lines. The concepts of distribution we have already discussed in power systems 1. So we'll confine to transmission lines in this power systems 2. Basic theory of the transmission lines. What is a transmission line? What is it made of? What are various factors associated with transmission line? As we are using a transmission line as a medium of power transfer from generating station to load centers, what is the operational efficiency of the lines? Operational efficiency means for transmission lines, we'll be more concerned about the efficiency of transmission and voltage regulation. So the theory of transmission lines, modeling of transmission lines, and performance analysis of the transmission lines will be discussed in this. Next, when the line is in operation, there will be various transients coming to the picture because of the variety of the consumers and fluctuations in the load on the system. So the transient in power systems will also be considered in power systems 2. Then the power factor and the voltage profile are very important for the consumers. Power factor should be close to unity. Voltage should always be available at the consumer premises at its required level. Therefore, we'll also be focusing on the methods to improve the power factor and to control the voltage effectively. Apart from this, the erection of transmission lines should also be understood by us. You might have observed various transmission lines On roadside, the lines we see are mostly distribution lines. Transmission lines are run with the long spanning, hundreds of kilometers. They take support of towers. They are called transmission towers. Towers are of different structures. Transmission line conductors are suspended to the towers. To suspend the conductors to transmission towers, there should be adequate insulation between the tower and the conductor, because the conductors will be operating at very high temperatures, very high voltages. The reason for transmission lines operating at very high voltages, for the same power to be transferred, when the voltage level is more, the power loss in the line will be less. Simple calculation by using I square R loss. When the voltage is increased, current decrease. The decrease in current helps in decreasing the power loss in the form of I square R. And the insulators are also very important. What is the spanning between, what is the distance between the supporting towers? How the transmission line or the conductor is designed, its mechanical strength. How does the line behave when it is in operation? Why is the sag and the tension in the conductor will also be discussed. And in the transmission, we'll also be using cables. Cables are of several types. Transmission lines, the difference between transmission lines and conductors is transmission lines, overhead lines and cables. Overhead lines are bare conductors suspended above the head over the surface of it, and the conductors are displaced with certain distance between them. So insulation, interconductor insulation, insulation to earth is provided by air itself. Whereas a cable is a bundled conductor. Cable will have number of leads for several phases of supply. And the cables will need adequate insulation for earthing as well as interconductor insulation. And as the cables are run under the ground, the required mechanical strength, insulation, moisture protection, etc. are to be considered. All these things will also be learned in the course of power systems. Then all these aspects, ranging from parameters of the lines, modeling, evaluation of the performance, evaluation of transients in the power systems, the concepts like power factor improvement and voltage regulation, mechanical design, insulators, cables will be discussed in power systems. The objectives of learning power systems. As we have mentioned, the transmission lines are designed with certain material. The property of the material is to offer certain resistance by the simple equation OL by A. When a conductor is designed with certain resistivity rho or a certain length L, having a cross section A, it will have a resistance rho L by A. The thing is, this resistance component, when compared to the inductance and capacitance of lines, will be less significant. The inductance and capacitance of the lines are of more significance. They will be affecting the efficiency and regulation of the lines. So once we erect a line, once we plan to erect a line, to decide the distance between the conductors, which in turn decides the structural design of the supports, line supports, and to decide the height above the ground level, we should have an approximate calculation of the inductance and capacitance values, because inductance and capacitance will be affecting the operational performance of the transmission. So at first, we'll be looking at inductance and capacitance of the transmission lines. And while estimating the inductance and capacitance, we'll be coming across the concepts like GMD and GMR. Geometric mean distance. GMD stands for geometric mean distance. GMR stands for geometric mean radius. When we compute the inductance and capacitance values, we'll be understanding these GMD and GMR clearly. Then, transmission lines are categorized as short, medium, and long transmission lines. Short, medium, and long transmission. In this course, we'll be bunching the short and medium lines in one set and long lines in another set. For medium transmission lines, we try to model them as you can remember from circuit theory, transmission line parameters. When you discuss Z parameters, Y parameters, H parameters, you'll be studying transmission parameters also, where you discuss A, B, C, D. So the transmission lines will also be modeled to obtain the values of parameters A, B, C, D. Using those parameters, we'll be estimating performance of the lines. By performance of the lines, it means estimating the efficiency of the line and voltage insulation of the line. Then the case of long transmission lines is different again. Short and medium transmission lines can be taken into a single set. Long lines are different. Long transmission lines are different. So the analysis of long transmission lines will be discussed separately. Someone is using their video, please turn off. I request all of you to turn off your videos, please. If you turn off your video, the quality of class will be good because it needs network data. Less data will be sufficient, and that helps you in attending all the 4 classes also. Thank you. Long transmission lines have to be treated separately because the parameters of the line, resistance, inductance, capacitance, and conductance, are not concentrated. They are distributed across the line. For long transmission lines, we cannot simply treat as we treat the short and medium length lines. They should be treated separately. So long transmission lines will have rigorous line calculations. Considering the receiving end, we'll be estimating the voltage and current values at any point in between the sending end and receiving end. And we'll be able to estimate the efficiency and regulation concepts at that point of line. Then traveling waves, effect of traveling waves on the transmission lines will also be discussed. The factors affecting performance of transmission lines and the power factor performance. What are the factors affecting performance of lines? The distance between the conductors and the material used for conductor will be considered to evaluate the performance of the lines. The power factor plays a very important role in the operation of power system. So we'll be focusing on the power factor aspects of the system also. When a transmission line is erected, as the line is suspended between two supports, two towers or two poles, the transmission line will not be a straight line between the two supports. I think you visualize this. The transmission line will not be a straight line between the two supports. It will be slightly in the form of a catenary. It will have a lower arc. That property of the line is called sag. And the conductor will also experience tension. So it is important for the design engineer to estimate sag and tension in the transmission lines and design the distance between the supports, height of the supports to make the operation effective. While we design, we need to consider the climatic conditions also where the lines are erected. A location may be experiencing severe winds in seasonal basis, or in Western countries, the lines may be covered by operation and light. Someone is speaking. So we need to discuss sag and tension. And we should also know insulators or line insulators. What are different types of insulators? What is the material used for insulators? How does the insulators have to be selected? Insulation strings, potential distribution, method of equalizing potential will all be discussed in power systems. Then we'll go through chapter by chapter. In the first unit, we'll be dealing with transmission line parameters. As we have already discussed, transmission lines are conductors of electrical power. The material used for conductors has to be learned. There are several types of conductors. They should be understood. When a conductor is designed, it will have a resistance. The resistance value may be calculated. The placement of the conductors will be affecting the values of inductance and capacitance. We'll be first considering the inductance evaluation for single phase lines and three phase lines. In the process, we'll be discussing the concepts called geometric mean radius, geometric mean distance. And in three phase lines, we'll be coming across symmetrical and unsymmetrical placement of the conductors. When the three conductors are placed with equal distance among them, they are called symmetrical lines. When not so placed, they are called asymmetrical space. Asymmetrical lines may be transposed or untransposed. Based on these several types of configurations, we'll be estimating the inductance of the conductors. Then we'll be solving certain problems based on this. Then we'll also be estimating the capacitance values. Yet our ground will have an effect on capacitance calculation. Capacitance is there is potential difference, and when there is an insulation between the two charges, will have a capacitance effect. Overhead lines are charged. They can be assumed to be two charged plates, and in between there is air. Air can be considered as dielectric. It is a simple capacitance effect. The charged conductor and the earth is at zero potential, conductor is at a higher potential. In between we have a insulation. So that is capacitance. So we'll be studying capacitance of the lines, and we'll consider the effect of ground and capacitance evaluation. As we have done it in the case of inductance evaluation, we'll be evaluating the capacitance for single phase lines, three phase lines with symmetrical spacing, unsymmetrical spacing, and all. Then, once we are aware of estimating the inductance and capacitance values of the line, it is important to evaluate performance of the lines. As I have already mentioned, transmission lines may be categorized as short, medium, and long. Short and medium lines can be put together to analyze in the same fashion. Long lines will be treated separately. So to evaluate performance of short and medium lines, we'll be modeling the lines. Modeling means we'll be, as you know in circuit theory, nominal T and nominal pi configurations. Transmission line constants means ABCD parameters. Estimation of ABCD parameters by modeling the line as nominal pi or nominal T will be done. This will be done for both symmetrical and asymmetrical networks. We'll be solving some numerical problems by nominal pi and nominal T configuration of the lines. And we'll be solving some problems also. Then performance of the long transmission. Long lines cannot be modeled as we model short and medium lines. Long lines will be evaluated by using rigorous line calculations. Using rigorous line calculations, we'll be estimating the ABCD constants irrespective of the long line equations. We interpret the long line using rigorous line calculations in the form of ABCD constants we do in short and medium lines. These ABCD parameters are entirely different. They are calculated by rigorous solutions. We'll develop some equations to estimate the voltage and current at any point between sending end and receiving end. We'll be learning about incident, reflected, and refracted waves. We'll also be learning surge impedance loading. What is a flat line? What is an infinite line? All these concepts will also be discussed here. Wavelength and the velocity of propagation of waves. And we are not going to nominal and nominal pi and nominal T configuration, but equivalent pi and equivalent T configuration. We'll be using rigorous line calculation. Next chapter is power system transients. What are different types of transients? What is propagation of such or traveling of such? What do you mean by attenuation, distortion, reflection coefficient, and refraction coefficient? How to terminate the lines under different conditions? What is an open circuited line? What is a short circuited line? What is T junction? Dumped reactive. All these factors will be discussing in power system transients. Discussing all these factors in power system. Now, the next topic is various factors governing the performance of transmission line. When a transmission line is operating, we'll be coming across various factors: skin effect, proximity effect, effect of resistance, Ferranti effect, charging current, shunt compensation, corona. When we discuss corona, we'll be discussing the phenomenon, visual critical voltage, disruptive critical voltage, and the factors associated with corona, radio interference. And in the last chapter, we'll be discussing sag and tension calculations of overhead lines and overhead line insulators. As I have already mentioned, when a line is suspended between two supports, it will have a sag and it will also experience a tension. We should be estimating these two parameters, the sag and tension in the line, before we erect the line. For this reason, in certain cases, we should also consider the climatic conditions and environmental effects, like the wind and ice loading on the line. So we need to consider all these aspects, and we should be able to estimate the sag and tension in the line. Suppose if two transmission line supports are of same height, if a conductor is suspended between the two supports, the conductor will form a catenary and the bottommost point will be almost at the middle of the two supports. But if the two supports are at different heights, the maximum sag point will not be at the midpoint between the two supports. It will be somewhere away from the midpoint. That we'll be discussing. We'll solve some problems. We'll calculate the stringing chart, sag template, and applications. And in insulators, we have insulators, glass insulators, pin insulators, shackle insulators, suspension disc, string insulators. When we come across string, we'll be estimating potential distribution. Then method of equalizing potentials, capacitance grading, static shielding, all these aspects will be discussed in the last unit. With this, we finish this class, and from tomorrow onwards, from the next class onwards, we'll be starting with the first chapter, transmission line parameters. As I have already mentioned, I request all of you to maintain a separate notebook and to complete the notes regularly. Hope every one of you are having a textbook with you. I prefer Sony Gupta Bhattnagar to prepare